In the past, the Yunlin area relied on groundwater as its primary water source. With industrial development and population growth, the Jiji Weir was commissioned in 2001. It serves as the central hub for coordinating and allocating water resources from the Changhua River, managing 2 billion cubic meters of water annually. In addition to supplying agricultural water to the Changhua and Yunlin areas, it also provides domestic and industrial water through the dedicated water routes of the Linnei Water Diversion Works, Douliu Canal, and Linnei Water Purification Station. The water supply facilities in Yunlin include the Jiji Weir, North and South Bank connecting channels, Douliu Weir, Linnei Water Purification Station, Linnei Water Diversion Works, Offshore Industrial Park Tailwater Pool, Tongtou Weir, Hushan Reservoir, and Hushan Water Purification Station. In the previous episode, we introduced the Jiji Weir and the North and South Bank connecting channels. This episode will continue to introduce other facilities in the Yunlin water supply system. The Douliu Weir is located 1 kilometer upstream from the confluence of the Changhua River and Changhua River in Linnei Township. Originally the water intake point for the Douliu Canal, it was expanded and put into use in 2002. The redesigned Douliu Weir water intake point is located next to the old water intake point on the south bank and connects to the south bank connecting channel of the Jiji Weir. It is designed to withdraw water with 40 cubic meters per second. The Douliu Weir is a crucial component in the joint utilization of water resources from the Changhua and Chiayi rivers. Besides assisting with the sediment flushing operations of the Jiji Weir, it can also serve as an alternative water source for the weir in emergencies. The Douliu Weir is a free overflow weir, 890 meters long, with a weir crest elevation of 109 meters. The sand sluiceway is located at the left end of the weir body and consists of 3 gates controlled by sluice gates, with the gate base elevation at 105 meters. The new water intake point is located to the right of the sand sluiceway and is designed to withdraw water with 40 cubic meters per second. It has 7 intake gates. To the left of the sand sluiceway, there is 1 fishway to facilitate the upstream migration of aquatic organisms such as fish and shrimp. The Linnei Water Diversion Works has 2 water intake gates and 5 diversion gates. It is an octagonal structure with a diameter of 100 meters, covering an area of 8,660 square meters and a depth of 6.8 meters, with a water storage capacity of approximately 45,000 cubic meters. In addition to its water diversion function, it also serves as a storage adjustment, stilling, and sedimentation facility, making it the most distinctive feature of the South Bank connecting channel. The water intake facilities include 2 sets of intake gates from the South Bank connecting channel and 2 sets of Linnei No. 2 water gate. The South Bank connecting channel sources its water from the Changhua River. After water is diverted by the Jiji Weir, it flows through a diversion culvert and the South Bank grit removal tank, merging into the water diversion channel. The Linnei No. 2 water intake point sources its water from the Changhua River and serves as one of the water sources for the Linnei Water Diversion Works. Between the Linnei Water Diversion Works and the water intake point, there is a dual-chamber grit removal tank with a flow rate of 54 cubic meters per second, each chamber measuring 30 meters in width and 120 meters in length. Each chamber has a sediment capacity of 7,200 cubic meters, with a maximum sediment grain size of 0.2 millimeters. The water diversion facilities are divided into 5 lines, including 5 Changhua Main Canal check gates, 3 Changhua Hydropower Plant check gates, 1 Mayuan Branch Canal Diversion Gate, 1 Wutu Branch Canal Second Water Intake Gate, and 4 Industrial Water Diversion Gates. Water from the Changhua Main Canal check gates is directed to the Shilua area in Yunlin for agricultural irrigation. Water from the Changhua hydropower plant check gates is used for power generation, with excess water discharged back into the south bank connecting channel. The Maiyuan branch canal supplies irrigation water to Xitong Township in Yunlin. The Wutu branch canal, via a culvert, supplies irrigation water to the Wutu area in Linnei. Industrial water is delivered through dedicated pipelines to the Mailiao Offshore Industrial Park. The Mailiao Offshore Industrial Park is located on the south side of the Changhua River estuary. It was originally a beach area that was developed through sand reclamation and dynamic compaction. The industrial water for the Mailiao Offshore Industrial Park comes from the Linnei Water Diversion Works. A dedicated 42-kilometer-long water pipeline delivers raw water to the Mailiao Industrial Park. The dedicated facilities include the water intake section, intake gates, a partial flume with a throat width of 15 meters, water pipelines, and a 20-hectare tailwater pool within the Mailiao Offshore Industrial Park. The tailwater pool, located within the industrial park, is a semi-underground structure with a storage capacity of 800,000 cubic meters, sufficient for the one-day maximum water demand of the industrial park when fully developed. Due to the turbid water quality and fluctuating flow rates of the Changhua River, Yunlin County previously relied on groundwater for its water needs of 260,000 cubic meters per day. Additionally, coastal aquaculture primarily relies on groundwater extraction, leading to increasingly severe land subsidence in some areas. This subsidence has gradually shifted from coastal regions to inland areas. To mitigate the subsidence rate around the high-speed rail, the government approved a well sealing project within a 3-kilometer radius of the high-speed rail line, with the affected water sources being replaced by alternative sources. Consequently, the Water Resources Agency planned to construct the Hushan Reservoir on the western foothills of the Douliu Hills. During the wet season, surplus water from the Changhua River would be stored in the reservoir for use during the dry season. The Hushan Reservoir is an off-stream reservoir, with its water source supplemented by trans-basin diversion from the Changhua River via the Tongtou Weir. Construction of the dam began in 2008, and it was put into operation in 2016. Its primary purposes are to provide domestic water, agricultural irrigation, and aquaculture water to the Yunlin area, thereby alleviating land subsidence and groundwater pollution issues. Upon completion, the reservoir can work in conjunction with the Jiji Weir to regulate water resources, drawing water from the Jiji Weir during the wet season and utilizing the Hushan Reservoir's stored water during the dry season. The Tongtou Weir is located in the mainstream valley of the Changhua River, a tributary of the Changhua River, and serves as the primary water source for the Hushan Reservoir, with a catchment area of approximately 259.20 square kilometers. Its primary function is to divert water from the Changhua River across the region to the Hushan Reservoir for storage and use. The intake flow rate is 20 cubic meters per second. The main facilities include the Weir, ground sill works, water intake point, sluiceway, grit removal tank, and trans-basin diversion headrace. The Weir is 91 meters long, 19.7 meters wide, and has a crest elevation of 222 meters. It is a straight drop, free overflow weir. The ground sill works are located downstream of the Tongtou Bridge and Xingjing Bridge near the Tongtou Weir and help control the river gradient to stabilize the riverbed and prevent erosion. The water intake point is located on the left bank side of the sluiceway, with 5 openings, each 4 meters wide, designed to draw 20 cubic meters per second. The sluiceway is on the left bank of the weir, featuring vertically operated fixed-wheel gates, with control gates and maintenance gates at the front and rear. The gates are 7 meters wide, with a sill elevation of 218 meters, and there is a fishway beside the sluiceway. The grit removal tank is located at the end of the diversion culvert connected to the side channel of water intake point, with a design flow rate of 20 cubic meters per second. It is 147.5 meters long and has 8 sedimentation troughs. The Trans-Basin Diversion Headrace is 3.842 kilometers long. Its function is to transport part of the water from the Changhua River, collected at the Tongtou Weir water intake point, through channels, pipelines, and tunnels to the Hushan Reservoir for storage and use. The water intake process for trans-basin diversion at the Tongtou Weir involves raw water from the Changhua River entering the water intake point, flowing into the grit removal tank for sedimentation, where the cleaner upper layer water flows through a partial flume for measurement, and then the water is transported via the diversion headrace to the Hushan Reservoir, completing the trans-basin diversion task. The dam engineering includes the Hushan Main Dam at the Tudigongking River, the Hushan Minor Dam at the Zhongking River, and the Hunan Dam at the Nanshiking River. The dam cross-section uses a central clay core zone and rolling stone dam design, with a crest width of 10 meters, a crest elevation of 216 meters, and a maximum height of 75 meters. The spillway of Hushan Reservoir is a semicircular free overflow weir with an open channel flood discharge design. The purpose of the construction tunnel was to divert the upstream waters of the Nanshiking River and the upstream waters of the Zhongking and Tudigongking rivers to facilitate the construction of the reservoir. The construction tunnel includes the 575-meter-long Hushan Tunnel and the 495-meter-long Hunan Tunnel. After the construction was completed, it was converted into a water intake and outlet conveyance pipeline. The water intake structure, also known as the Reservoir Intake Tower, primarily functions as the outlet for reservoir water. Hushan Reservoir has an inclined water intake tower with an angle of 30 degrees to the horizontal plane. The inclined intake tower has upper and lower intake openings at elevations of 180 meters and 165 meters, respectively. The front end of the tower has a trash rack to prevent large debris from entering the conveyance pipeline. A stop gate is installed on the upstream face of the intake tower partition wall to control the opening and closing of the upper and lower intake openings. This allows for adjustment based on the water quality conditions in the reservoir. The outlet works are the structures that transport water from the intake tower through a conveyance tunnel to the terminal structures. It includes a valve chamber and a sluiceway, with various hydraulic gates in the valve chamber to control reservoir water discharge in emergencies, normal ecological flow release, and supply raw water for domestic use. With the construction of the Hushan Reservoir, the Hushan Reservoir Downstream Water Supply Project was also initiated. This project involves the joint utilization of water sources from both the Hushan Reservoir and the Jiji Weir to supply public water to the greater Yunlin area. Construction began in 2012 and was completed in 2017, spanning 6 years. The main components of the project include the raw water diversion pipeline, pre-treatment facilities, and the Hushan Water Purification Station, which together form a comprehensive water supply network for the greater Yunlin area, providing stable water security. The estimated maximum water supply is 432,000 cubic meters per day, which not only meets the water needs of Yunlin County but also allows for the distribution of water to support Changhua and Chiayi, effectively addressing the long-standing issue of excessive groundwater extraction. The water intake point for the water supply project is located near the intersection of the Douliu Main Canal's first diversion route and the Douliu River. It draws raw water from the south bank connecting channel of the Jiji Weir as the water source for the pre-treatment facilities. The raw water diversion pipeline transports raw water from the Hushan Reservoir to the pre-treatment facilities or the water purification station. The pipeline is approximately 12 kilometers long. The Linnei Water Purification Station, which sources its water from the Jiji Weir, deals with raw water of very high turbidity. To reduce this turbidity, Taiwan Water Corporation, in conjunction with the Hushan Reservoir Water Purification Station project, established a 37.2-hectare pre-treatment facility in the Dingzhuang section of Linbei Village, Linnei Township, in 2014. The main facilities include grid removal tanks, sludge wells, sludge lagoons, and sludge drying beds. The water delivery process for the pre-treatment facilities is as follows. raw water from the south bank connecting channel of the Jiji Weir is transported via the water intake point and pipeline to the pre-treatment facility. The water and sediment are initially separated in the primary settling tank, and the water is then sent to the Linnei and Hushan Water Purification Stations for further purification steps. The Linnei Water Purification Station, located in Linnei Township, was completed in 2006. It was constructed as part of the Jiji Weir Joint Water Diversion Project. During the wet season, the water source is the south bank connecting channel of the Jiji Weir. In the dry season, the water comes from the Hushan Reservoir. The station has a designed output capacity of 198,000 cubic meters per day. The equipment at the Linnei Water Purification Station includes a raw water regulation basin, distribution well, flow measurement flume, flocculation basin, sedimentation tank, rapid sand filters, clear water reservoir, wastewater basin, sludge thickener, and sludge drying beds. The water purification process begins with raw water entering the raw water regulation basin through the water intake point, then passing through the distribution well, flocculation basin, sedimentation tank, and rapid sand filters before finally reaching the clear water reservoir. The purified water is then distributed to the urban areas for residential use. The sludge is directed to the sludge sedimentation basin for concentration and drying. The Linnei Water Purification Station supplies water to southern Yunlin areas, including Douliu, Donun, Toku, Yuancheng, Begang, Shualin, Linnei, and Shilua, and parts of Changhua, including Zhuteng, Shizhou, and Erlin, as well as Minxiong in Chiayi. The Hushan Water Purification Station, located in Douliu City, was completed in 2016. Its primary water source is the Hushan Reservoir, with additional raw water supplied from the south bank connecting channel of the Jiji Weir. The station has a designed output capacity of 400,000 cubic meters per day. The equipment at the Hushan Water Purification Station includes a raw water regulation basin, flow measurement flume, flash mixer, flocculation basin, sedimentation tank, rapid sand filters, clear water reservoir, sludge thickener, sludge sedimentation basin, sludge drying beds, wastewater basin, and a wastewater regulation basin. The water purification process begins with raw water entering the water intake well, then passing through the raw water regulation basin, flash mixer, flocculation basin, sedimentation tank, and rapid sand filters before finally reaching the clear water reservoir. The purified water is then distributed to Yunlin, northern Chiayi, and southern Changhua urban areas for residential use. The sludge is directed to the sludge sedimentation basin for concentration, drying, and recycling. The Hushan Water Purification Station supplies water to northern Yunlin areas, including Mailiao, Taishi, Sihu, Dongshi, Huwei, and Baozhong. In addition to these two main water purification stations, Yunlin also has several other purification stations, such as Luanbei, Mailiao First, Conjiao, Guqing, Sihu, and others. Currently, the various water purification systems in Yunlin have been consolidated into the Yunlin water supply system. In the past, water sources in the Changhua-Nantou, and Yunlin areas were primarily from groundwater. However, with population growth and industrial development, water demand increased, leading to over-extraction of groundwater. This caused land subsidence along coastal and inland areas and significantly impacted the operational safety of the high-speed rail. In recent years, new water sources have been actively planned in these regions, including the construction of the Niaozuitan Lake, Jiji Weir, and Hushan Reservoir, to increase the supply of surface water and mitigate land subsidence. Today, we enjoy an ample supply of water for both domestic and industrial use, and the conveniences of modern life, thanks to the efforts and contributions of those involved in public water supply projects.